Number 3 on 2019 free response questions. I do want to look at the cues and main ideas because it's a little bit more complicated question. It's got a lot of things to it. So I want to look at, what on this in this question is telling us to do what. So the first thing that I see here is a graph that is composed of line segments and semicircles. In fact, generally speaking, they're going to say that. It says the figure shows a portion of the graph consisting of 2 line segments and a quarter of a circle. All right, so if I see a graph made out of lines and semicircles, those are things that I can compute the area geometrically. So I'm probably going to be doing this. I'm going to be finding the integral using area. So when I'm doing that, I should watch out for if the curve goes below the x-axis, I'm going to have negative area. So I see that going on here. I'm also going to be thinking about, I might need to reverse the order of the limits. So if I need to find, they ask me about an integral that goes from a larger number to a lower number, I might need to turn that around. So I have integral b to a here. I might need to turn that around to integral from a to b. When I do that, I put a negative out front. So those are things I can be looking out for when I see this kind of a graph. Also, by the way, I do see that they gave us a specific value too. So another thing that I'm probably going to be looking out for that I didn't put on here yet, since we have a specific value and some integrals, I have a specific value and the possibility to do integrals, I should be thinking about that f of b equals f of a plus integral from a to b of f of x dx. So I'm just guessing from the look of the problem that that's going to come into play somewhere. It might not, but it sort of looks like it might. All right, and then what else do I see here? I see someone's asking me to do an integral of something that involves f prime. So I'm doing an integral of a derivative. So that's part of your fundamental theorem of calculus, is that integral and derivative cancel out in some way. So if I'm doing an integral of a derivative, I need to be thinking that that definite integral is just going to be f of b minus f of a. And since I have a graph up there of f, I can get these values over here and use them to answer questions about this sort of thing. Then what else I see is a function g that's given by an integral from -2 to x of f of t dt. So I see that these two variables match, but they're different from the other two. What I'm looking at is the fundamental theorem of calculus, the other part, where I'm doing the integral of a derivative. And what this is basically telling me is that f is the derivative of g. So when you see something like that, we define a new function g of x. They love to do this. It's one of their favorite things. And then remember, whatever your number down is here, the -2, doesn't matter what it was. That -2 is irrelevant. Because you're essentially looking at a derivative, the constant's going to go away. So when you see this, you want to be thinking, if g is the integral of f, that tells me that f is the derivative of g. And that tells me that when I'm looking at my graph here, which is a graph of f, and this tells me, values of f, that's also the derivative of g. So if they ask me about questions about g, then this is a graph of g prime, right? And if they ask me about f, then this is a graph of f. So I need to be thinking, about which function they're asking me about. But the key thing is when I see this type of integral definition, I just want to be thinking that f is g prime. That's it. So the graph of f is the graph of g prime. And then the last thing I see here is a limit, some kind of strange limit. It's got a bunch of weird stuff in it. So things that I should be thinking about when I get to the point of thinking about that limit, when I have that limit, I should be thinking, can I factor it somehow? Could I apply L'Hopital to it? Which means, is it a 0 over 0 form or infinity over infinity form? Or maybe I could evaluate it just by substituting. That's always worth trying. You should always try substitution first. However, on the AP exam, substitution is going to be sort of the least likely solution because it's so easy. So it's a little too easy for the BC exam. All right, so here are some of our cues and main ideas. Just starting, when I look at a huge problem like this, what are some of the things that this cues me to think about? And these are some of the cues and the main ideas they lead to. So we'll see how those lead us to be able to solve some of the problems.